Well, hello friends. Welcome to the first episode of Code Review. A bunch of people have suggested that since I'm doing so much code review lately, why don't I show that in a video? So that's what we're going to do today. We're going to review a pull request and show the process. So there's one in the queue that I thought we could do, which is this one from Gunnar Beutner, called Profiler, Various Improvements for the Profiler. Nice and huge scope, potentially. So Gunnar has been doing a whole bunch of things to the Profiler, and I guess we're gonna review all of them. So let's just take a look at these. So max stack frames increased to 64 because we were hitting the previous limit. So I'm well aware of that issue, actually, so let me show you what that's about. I guess we can take a look at, try to reproduce any bugs before we look at the fixes for them. So the stack limit issue is that if you run some complex program like the browser, and then we start profiling the web content process here, and then we do something, I don't know, a little bit of selecting, then what happens is we get multiple outermost entries here in the call tree. And really this doesn't make a lot of sense. Like, everything should be below the same one. It's just that if we look at the samples here, this is like each sample. So the limit is currently that we can only have 32 frames in the sample. And this sample right here, that's not so many frames, but if we look through here, we can see that sometimes when the call stack gets deeper, because of recursive algorithms, especially common in the web browser, but also in other stuff, eventually 32 stack frames is not enough. So we end up cutting off stuff, and we keep the innermost frames just because that's sort of the more relevant frames when you're doing a profile. So we lose some of the outer frames, and that's why our call tree ends up looking like this, because we had the call stack in some samples don't start at the same place that they normally would because of the cutoff point. So max stack frames increased to 64. Let's see if that's a separate commit, actually. That would be cool. I guess here probably increase max frame count to 64. Even just profiling piano hits the previous limit. Sure. Yeah, so he's just increasing the max stack frame count to 64 here in the performance event. Let's see what that is. Performance event. Yeah, it's right here. This static const expert size t. So the way that we store profiling events is it's like a long array of performance event objects, basically. And every performance event that a process logs has the same metadata, and then it has a union of a couple of different types. Currently we have malloc performance event and free performance event. These are used for memory allocation profiling, and we put those in a union because you might want to have different types of information about different types of performance events. So it's just a classic union thing. And right now these two actually happen to look the same, but I guess if we add more event types, we'll end up with some other stuff in the union that does not look the same. But the single biggest chunk in each performance event is the call stack, which is right here. So the stack is what you see in the sample view. Like, each one of these entries over here on the right hand side, these are entries in this pointer array called stack here. So now this commit here simply grows that one from 32 to 64, which will still cut off anything that recurses deeper than 64 levels, right? But it's an improvement. The annoying thing is that if you increase that, you increase the cost of every performance event, even those that don't have such deep stacks. So it's a balance thing. we might want to eventually look for a way to only charge each performance event for the actual number of stack frames it has. But right now, it's just a simple array, so that's why we end up with that linear cost. Okay, so that one is good. And then let's see what else he was talking about. Stops walking the stack when we encounter a return address of 0. So that would be probably this commit right here. So just take a look at that. Okay, so in raw backtrace, we insert a 0 check. So this is the code in the performance event buffer class. This is used when creating perf events. It's the thing that we actually use to populate this array right here. And when we walk the stack, we read the return address pointer from the stack and then append that to the backtrace. But I guess, so basically it's just saying if we hit a 0, we can just stop right away instead of adding it. So what that will achieve is that we won't have a 0 at the bottom here, which makes sense because it's useless. The 0 is not semantically relevant, it's just a sentinel value. So the entry point of this sample here, it should be start, not 0, because we didn't enter the process at address 0. So I think that's a good change as well. We'll clean up those samples a little bit. Okay, and then fix argument type for JSON array. Wait, was that mentioned? Didn't see anything with JSON array. Well, let's look at this. Fix argument type for JSON array at and JSON array operator bracket. Okay, so this is just for the JSON array class in the ACK library, changing at and operator bracket to, or subscript operator, if you will, from int to size t. That's fine. Nothing particularly interesting about that. It's just a nice cleanup. I'm guessing that avoids some warning that would happen otherwise in subsequent code. Okay, and then we have one big monster commit for everything else, it seems like. So that would be, wait, what's the keybind? It's N to get to the next one, right? Yeah. Okay, so this is the remaining commit. So let's see what he says. This turns the perf core format into more a log than it was before, which lets us properly log process, thread, and region creation destruction. Okay. This also makes it unnecessary to dump the process regions every time it is scheduled like we did before. Right, so let me give you some context on that. So when you generate a profile in Serenity, what you're really doing is you're telling the kernel to start recording what we call performance events for that process. So say that we have the running taskbar program, for example, which has process ID 16, and then I would say profile PID16 enable. So now I've instructed the kernel to begin sampling this taskbar process. So whenever I do something with the taskbar and it runs, the kernel will periodically log what it was doing. And then now I've disabled profiling for PID16. That message is a bit weird. I don't remember that being there. And now that I have done this, because the program is still running, if the taskbar process exits, it will dump a so-called perfcore file, which is a file in the current directory where the process was executing that contains all of these events as a long JSON string. But if you don't want to kill the process, you can still access the perf events of a still running process through the proc file system. So if you look in proc16, we can see that we have a file perf events here, and proc16 perf events, if we cat that, it's a bunch of JSON. So the kernel will just generate this JSON on the fly now. And if we open that with PV, or which is just a short for profiler, we can actually look at these events. And click on samples, and yeah, so we managed to capture a total of 5 samples with me screwing around there. Because one thing is that we only capture samples when the process actually runs on the CPU. So if you have a process that's primarily blocked in read or select or some syscall like that, you don't end up with any samples, because we currently only sample when the process is scheduled to run on the CPU. That's a potential future improvement. Would be cool to have support for capturing samples even when a process is blocked, because then you could use that to build an idea of what a program is doing, why is it blocked, where is it blocked, stuff like that. Anyway, so that was just where the perf events are, what they look like. They just look like this JSON. Actually, let me JP that so we can see what each entry looks like in that file. So it's just a JSON array, and each sample looks like this. So it has a type sample, a thread ID, a timestamp. This is timestamp since boot, I think, in milliseconds. And then we have the raw stack. These are just addresses, return addresses from the stack. And then when you run the profiler program, it will take a list of whatever regions were mapped into that process at the time and turn these addresses into symbols so that we can understand the profile. Of course, I guess to give some more context, the way that we capture all of those, let me copy this to a file. Call that P, and we can open it in the text editor. Okay, maybe that was not ideal. Yeah, that's a bit better. So at the start here, before we get to all the samples, we have a dump of some metadata about the processes involved in this sample, or in this profile. So you can see we have PID16, the path to the executable, and then a list of all the memory regions mapped into this process. And this memory region list here is particularly annoying because the way it has worked, at least until now, is that every time that we schedule a process, we would capture a snapshot of all the memory regions in that process at the moment of sampling. And we would do that every time you would sample a process. So really quite an expensive operation to walk the entire memory region set and produce this metadata. And it also has this problem that if something is mapped or unmapped, we lose all the historical information about what was mapped at which time. So a sample might contain an address that is no longer mapped into the process, for example. So that's a huge flaw of the way things currently are. But it does sound like we're going to improve that here. So I think let's just keep reading. So yeah, this makes it unnecessary to dump the process's regions every time it's scheduled like we did before. So that's something we were doing before, and I can show you how we do that. So every time that we schedule, wait, where is this perf? Oh wait, I guess it is here actually. Yeah, so for profiling all threads, we dump the current process's address space layout every time it's sampled. We should figure out a way to do this less often. Right, so it's this function here, add process. Add process. Okay, so previously we would call add process when you're sampling, when you're profiling the whole system, which you can do. You can profile either the whole system then we record perf events for all threads running, or you can profile a single process, in which case we only record perf events for that process. And I think when you do it for a single process, then we call add process once when you first instantiate the perf event buffer. And that means that you get a snapshot of whatever memory region layout you had when you began profiling. And if you are sampling all threads, then we do that in the scheduler. So in the scheduler, we just check, as long as we're not scheduling the idle thread, then we will call add process again, which will capture all the memory layout stuff. So that's very expensive. But then that has the flaw that if you only do a single process, then you end up with a snapshot of the memory region layout at the start of profiling, and whatever is added after that, you don't know about that. So let's see. Incidentally, this also fixes profile-c because we previously ended up incorrectly dumping the parent's region map into the profile data. Yeah, so that would be because of that, right? So profile-c is a command that we have, which you can use to generate a profile for another command. So here I'm profiling the ID command, and because it exits, it will dump perfcore. So we have it here. And then I have to sneeze. Excuse me. Yeah, so it generated a perfcore file. And if we look in that, we can see that probably, yeah, we can't make any sense of it. And that would be because profile-c works by enabling profiling and then execing another program. So when we enable profiling here, we would capture the profile program's memory layout, and then exec ID, and then begin capturing samples of ID. So this is a sample of ID here, but we are still trying to interpret that as if it's addresses in the memory layout of the profile program, which has disappeared at this point. We've execed, right? So that will be fixed by this patch. That's good. Okay, and then log-based mmap support enables profiling shared libraries which are loaded at runtime, e.g. via dlopen. Okay, yeah, so Gunnar has been working on dlopen recently, which means that you can add additional libraries to the program address space at runtime. And that's definitely not something that we supported nicely before. This enables profiling both the parent and child process for programs which use execva. Previously, we would discard the profiling data for the old process. Okay. The profiler tool has been updated to not treat thread IDs as process IDs anymore. This enables support for processes with more than one thread. Also, there is a new widget to filter which process should be displayed. So there's a lot of stuff going on in this commit. I think, personally, I would prefer that this would have been divided into maybe 2 or 3 commits. Certainly, adding a new widget to do filtering does not need to be mixed up with everything else, even though without that widget you might not see all the data that you want to see. I think it's still good just for atomicity to separate these type of things. So, and then, yeah, I mean, now we read the commit message to work out what this is about. I guess this is sort of the same information here, just in list form. And then we have a screenshot, and here's that filtering list. So, and here's me commenting, thank you for working on this earlier, by the way, because I'm very happy that Gunnar is working on this. The profiler is very dear to my heart, obviously. I love profiling and very excited about somebody else adding all this great stuff to it. So let's look at the hunks in this patch here. So first thing I notice here is GNU no inline. we usually have a macro for that. No inline. Oh, that's a regex. Goof. Never inline. Yes. Please use never inline instead of no inline. Okay. And then we're also adding a const char star argument to performance event buffer append. So performance event buffer append is the sort of the workhorse of the profiling logic. Where is it? Oh, is it this function right here? Oh, I guess he calls the workhorse append with EIP and EBP. So it's actually more like a helper wrapper that spills the current EBP, the current base pointer register, into a variable so that we can pass that along. Because we need the EBP to know where to start walking the stack, so that's why we do this. And then we call append with EIP and EBP, which is where we actually physically append a performance event struct to the array. Where do we do that? Oh, here. Oh, that's that's a really hard to read line. At returns in a reference to the array slot. So not a huge fan of that syntax, but it may also have been me who wrote it, so hey. Anyway. So here, what's going on? So adding arg3, third argument, and instead of grabbing the EIP from the current thread stack, we now append the PID and the TID. Okay. That's fine. We'll see what that's about. And then what do we have here? Raw backtrace. If EIP is not 0, then we append it. Okay, sure. So just more of that, like not adding 0 EIPs to the backtrace. I guess sometimes we would call here with a 0 EIP. Oh, is that this one right here? That's EIP? Okay, so if we're calling this function in this way, then we make sure that we don't have the top stack frame here. The innermost stack frame is not going to be 0. That makes sense, because symbolic hitting 0 will give you nothing. Sure. Okay, and then we're adding a bunch of new different types of perf events. So we have perf event mmap, munmap, process create, process exec, process exit, thread create, and thread exit. Right, so he's adding all these different types of perf events so that we're logging what is happening to the memory layout of the process rather than capturing a snapshot. And that's obviously better because that means that we will have sort of we will be able to play back what was happening, how the memory layout was mutating, and that means that at any given time in the profile, we're able to reconstruct what the address space looked like. And that means that we will be able to symbolicate everything correctly, even in the presence of inserting and removing dynamic libraries and stuff at runtime. So I see strlen here. That makes me suspicious. Why do we need to strlen? Why do we need to strlen? Strlen is const char star arg3. So that's the third argument to this function. So let's just scatter around here. Who calls this? Or actually, you know what? Let's just, oh, I have it already. So I'm just gonna ugly merge it onto my thing here. What was it called? Perf Events. Yeah. Oh, get. Let's do that. And then we can build it and look around. Okay, this is not super fast, so let's just look around. I think since the last video, I have cut down on the number of threads that I'm letting Ninja use, or at least I thought I had. It's supposed to be using 8 only. So let's see. Maybe I should let C-line index. So much going on at the same time. I wanted to take a look at that append with EIP and EBP. Right, so it has RH3. Why is that a const char star? Like, is that necessary? Can we use something smarter? So we have a bunch of usages. It's called here by the scheduler, passing a null putter. Null putter. Here we are passing a region name when we're adding a new process. Oh, interesting. Okay, so when we add a new process, then we will walk the memory layout of the process and create sort of the synthetic synchronous mmap events for every region that's already present. That's good, because that means that if you attach to an already running program, we will fake sort of mmap events for everything. Likewise, we will also walk the thread list and fake thread created events. That makes sense. Makes perfect sense. But yeah, so here we are doing region name characters. My hunch is that we can just use a string view instead. There seems to be no particular reason to use a const char star. So here we're passing the executable .characters, arch3. So we do have a system call that does these, which is called sysperf event. So he just passes null. Yeah. So I think we'll add a comment here. Also, I think arch3 can be a string view instead of a const char star. Then we won't need to strlen. Do a bunch of strlen on it in this function. Yeah, because oh wait, was that the function? No, it was this function. Oh, I'm mixing these up. Well, let me move that comment actually. Can I? Okay. I'll put that here instead. Oakley dokley. Yeah, because this was kind of suspicious, right? Like, why do you need to measure how long the string is when this the origin of the string is one of our own C++ string objects where we know the length already. Okay, so we're back on track. So we're appending an event, just creating the performance event data structure and shuffling stuff into the appropriate union substructure. Nothing particularly crazy going on here. And I guess we didn't see the definition of this. So how long can a executable name be? Performance event buffer, let's take a look. So I guess it's, I mean, it's right here, right? So 64 bytes is the maximum length of an executable. It's not terribly long, but it's also not unreasonable. Wait, what's going on here? Hello. That was a little weird. So let's see if we have a string like user local bin my very long program. Yeah, I mean that's 36 characters. It's not really an issue. Yeah, 64 is probably fine. Yeah, let's just live with it. I mean, we have to make some kind of decision or compromise on struct sizes here. We can't just go infinite because one of the things is that when we record a profile, we pre-allocate space for all of these events. So the reason we do that actually is so that the scheduler does not incur page faults while appending to it. So because of that, we pre-allocate a huge buffer that we record into, and then if we hit the end of that buffer, then we can't record anymore. Maybe it should become a circle buffer or something like that, or much better would be if user space would be sort of streaming these events or sort of draining the buffer somehow while we're recording so that it wouldn't run out of space, but that's a whole other issue. Let's go back to the patch. Okay, so something that's new is that we are now, instead of just grabbing the current thread ID, we actually take whatever was passed to us. PID and TID. Those are function arguments now? Yeah, PID and TID. Okay, so that's good. Yeah, when I last worked on the profiler, I was very casually just conflating the PID and TID stuff just to make progress, and I kept saying like, yeah, we'll get back to this, we'll get back to this, and it seems like now Gunnar is getting back to actually treating process ID and thread ID separately, so that's good. That's really good. Okay, and this code here is to JSON impulse, so this is the code that gets run when you try to read from like procpid perf events, or also when we generate a perf core file, basically walking the list of recorded events and then dumping out JSON to one of these JSON object serializers. So we can just look here, see that things sort of make sense. Very, very straightforward boilerplatey code. One thing that is a little bit, like, it is a little bit silly sometimes, I feel like, that we're putting like these stringly typed information into the JSON dumps. Like, we could emit numerical data instead, like instead of type being process create, it could be like type 5 or whatever, but it's not such a big deal. I think having a very readable format is more valuable than compacting it right now. I might change my mind on that in the future, but at the moment it's nice to have something very readable. Okay, to JSON, we're removing this code right here. So this is the code this is the function that you call when you want to serialize an entire performance event buffer, which is one per process. You would serialize this thing into a buffer builder, and what he's removing here is just the previous way that we would dump out the memory layout. So you can see how it works. When you would serialize to JSON, we would create the processes object in the JSON. Wait, is this thing running? No. The processes object, and then loop through the memory layout and dump out each region. So Right. Process regions. But all of this stuff is replaced now by the process create and mmap, munmap event stuff instead. So that's cool. Okay, and then performance event buffer add process gains a new parameter, event type, which we use to distinguish what? How the process, why are we adding a process, I guess. So it's either it's a fork or it's a what? It's an exec or a fork. Fascinating. Okay, yeah, so even if you are, right, of course. So if you're adding a process because you've exec'd, it's still the same PID. It's just, you're still, from the profiling perspective, we have to treat that as a new process. So we generate a new call to add process. And yeah, so this is just converting that enum to a perf event value. That seems reasonable. Okay, and then looping through the threads, adding the events. We already looked at this in context, so that's fine. Okay, and here are the new union substructures. Nothing crazy. mmap is a little bit iffy. It's like 64. I'm getting paranoid again. Like, aren't they sometimes much longer than 64? But let's actually look at that. Because maybe I'm just dreaming. Yeah, like even our longest was... This is not 64 characters. I don't know why I keep worrying about this. Okay. I gotta chill out on the, on the 64. Okay, sure. Yeah, so I already mentioned the arg3 thing elsewhere. And sample process. Okay, so we don't need to collect this data structure anymore. This was like a metadata structure that we had previously to capture information about each process in the profile. Of course, that has now been converted into these events instead, so that's cool. And we were stashing those in this hash map here previously. That goes away. Fantastic. And then what is this? And the process destructor. Okay, in the process destructor, if we are profiling all threads, then we will generate a perf event process exit with the current PID. That makes sense. Okay, so in the case that we are profiling, doing a global profile, not just a local process specific profile, we will just let the global profile know that this PID exited at this point. Very interesting, good information. Okay, and then when we create a perf events buffer if needed, process event type fork. So the connection between this call here and the fact that this is a fork, it does seem a bit flimsy. So I'm just going to make a note of that. The implication that it seems a bit flimsy to, or how do I express this? Does it make sense to always, or it feels a bit flimsy to say that we're always doing a fork when calling create perf events buffer if needed. The two concepts seem seem quite far apart. Perhaps this implication can, perhaps this could, perhaps we could express ourselves a bit more explicitly here. Sure. Yeah, sometimes it's hard to verbalize what seems strange about a piece of code, but I feel like it's still always worth trying. And if you don't really know exactly what to say, you can just sort of vaguely say things anyway. And this in particular, like striving to be more explicit about what's going on, I think that's always valuable. So I like to fall back on that when I don't know exactly how to articulate what I don't love about something. Okay, so this thing here disappears, where we would always recapture memory layout for every time we would schedule during global profiling. Super great, fantastic. Okay, and here is where the actual profiling really does happen. So this is in the scheduler. When the timer ticks and we have to schedule a new thread, whatever thread we end up scheduling, we log a perf event sample for that thread. We were doing that previously as well, so here he's just updating to pass in the current PID and the current TID. Let me look at that in context. Timer tick. So here is the previous, oh no, this is the current call, right? So process current PID, process and thread current TID. I think the one thing I would say here is that we should probably not use these unnecessarily, because we already have the current thread in a pointer here. So this thing will actually do some chunkier stuff, reading from a different segment. If we already have the this pointer and this pointer, then we should make use of those, I think. Yeah, so that would be my one comment here. Current thread instead of thread current here, and same thing for current thread process instead of process current. Okay, so now we're looking at the exec syscall. So previously, when you would exec, we would throw away all the recorded performance events. And now that's being changed here. So first he works out if we have a perf event buffer currently recording, and based on the profiling all threads flag, either it's this one for all threads or this one local for the process. And instead of clearing the perf event buffer, he simply adds a process event type exec to the buffer. That's very nifty. Very nifty indeed. I feel a little bit like in the profile-c case, I don't care about the profile process at all. Like, it would be fine to just forget everything about it. But I guess there's currently no way for the profile program to express that to the kernel, that like, you don't have to remember anything about me, I'm irrelevant. But at the same time, it's very, very likely that after you enable profiling, like the profile program is so simple. If you run with -c, basically it will enable profiling here, and then the very next thing that it does is call execva. So it will do a little bit of path resolution and stuff, but it seems unlikely that it will get scheduled more than once. So it's not the biggest deal, it's just something that comes to mind here, that if you could have a way of saying like, start profiling, And when I exec, you can forget everything about the previous process. But not super important. Okay, and then when you call sysexit to exit the current process, if we are profiling, oh no, then we just produce a thread exit event. That's fine. Sure. So this thread exited. Perf thread exit. Okay, that's okay. Event buffer. Append. I was just thinking about this thing here not being strongly typed. Like, we're not passing a thread ID, but we're extracting the integer value from it. But that's okay. Okay, and now the forks is call. If we're profiling all threads and you fork, then we will add the new process. Sure. And if you're running something, if you're profiling a program and it forks, we will not profile the fork unless we're profiling all threads. That makes sense to me. It makes sense, but it could be an interesting feature in the future, because imagine that you want to do something like profile GCC for compiling something. GCC operates by spawning a bunch of helpers, and if you just do profile-c GCC something, then you will only see sort of the driver program samples, which are not going to be any of the interesting work for compilation. So I'm just going to make a note of that here. It could be an interesting feature. It would be an interesting feature to also support optionally automatically profile forked children. This could be super useful for stuff like profiling something like GCC, which spawns a bunch of helpers to do most of the work. Yep. But I mean, I also like to add these type of notes while I'm reviewing. Not necessarily, I'm not saying that something here needs to be changed. This is just a note. And then after I add a note like this, I also often remember to say, obviously, this doesn't need to be done in this PR, obviously. Because if I don't say that, then sometimes people think I mean that they should do it now. But I'm just making like a note of something. Okay. And where are we now? We're in mmap. So whenever you're doing mmap, let's see. Wait, what's going on here? Profiling all threads. So we generate a perf event mmap. This looks sketchy to me because of this check right after here, if not region, because he's dereferencing region right here. So if we fail to allocate virtual memory, then this would crash. So if you run out of VM, this should be after the if region check below. Otherwise, we'll deref. We'll get a null dereference on VM allocation failure during profile. Yeah, so that's a bug. Yep. Multiple dereferences here. Okay, but basically what the code is about is just logging the fact that an mmap event took place. So that's good, and we log sort of the final state of the region after it has been padded to or aligned to like page size boundaries. Okay, and then if you do set mmap name, then we will log that as an mmap event as well. Okay, interesting. So renaming a region will be logged as an mmap. That's fine. You could imagine having a finer, more specific event for region renames, but doing it as an mmap is fine too. It doesn't really matter. Okay, and then munmap. After you have munmapped, you just generate a perf event munmap. Sure. I'm starting to think that we should have a helper to express this, because this is a recurring pattern, right? Like fetching the event buffer, either the global event buffer or the process local one. So sometimes I realize halfway through a patch that like there's a repeating pattern, and maybe I should go and like find the first instance of it, but I can also just put it here. So this pattern keeps recurring. Maybe we can make a helper for it. What would it look like? Maybe something like if auto event buffer current perf event buffer. Not sure about a great name, but something like this. Yeah, and actually we should probably do it like that so that we don't accidentally copy anything here. But yeah, basically just to get this branching out of these places, because it's better to not have this type of thing repeating, I think. Also, this pattern is kind of awkward, that you have to put the result of append into a temporary and then maybe unused it. This is all just cruft to avoid a compiler warning, basically, because this function is no discard. And it's not even explicitly no discard, it's just that it returns a k result. And k result itself is no discard. And you know, it's not perfect, but at the same time, when it comes to surfacing errors that happen on sort of not on the specified POSIX path of something, so say that you're mapping, and then we also happen to record a profiling or perf event about the fact that you mapped, and something goes wrong with that, but the mmap itself is just fine. Should we return an error from mmap for that? I don't think so, because mmap went okay. It's just that our little probe that we were using to profile stuff, something happened with that. But really, whoever called mmap doesn't care about that and shouldn't find out about it. So you would want this error to propagate out to whoever eventually reads from the perf event buffer, but it's not obvious to me how to do that in a clean way. But it's also not something we have to solve here and now, obviously. Okay, so then just the two different paths in mmap, hold range or partial. That's fine. Perf event, just adjusting for the new function header. Okay, moving the order here of the these two variables, probably super important. And then what's going on? When you enable profiling, we will... Wait, what is this? Global perf events. Okay, so this is when we enable global profiling, we now walk the list of currently running processes and create a fork event for all of them. Makes perfect sense. Makes perfect sense to me. Okay, and when you create a thread, we create the thread thing. Sure. And when you exit a thread, we do the thread exit. Yeah. So these are all good. And here's the C API, or no, this is Unix types. Okay, yeah. So this is just, we need to have these so that we can, so that the kernel and user space can talk to each other in a way that makes sense to both of them. We need to have these perf event values in enum here. Unix types.h is an annoying thing. It's like we duplicate a lot of libc constants in Unix type.h simply because it gets really messy if you try to include libc headers in the kernel. So instead of doing that in a nice way, which I guess would be to divide libc headers into like a bits subdirectory that has tiny little bits that the kernel could include, for example. Instead, we have this mess where we have like everything duplicated in Unix types.h. I'll show you that thing. It's a kernel file. It's this big, ugly mess that has just a mix of random libc macros and structs and stuff. I wonder if libc bits is the right approach, or even if the kernel should have a directory, like an API or POSIX API directory with header files that libc could include. Maybe that would be the best approach. Because I mean, really, like, the kernel shouldn't depend on libc. It should be the other way around. But now I'm getting distracted by something unrelated. So let's get back on track. Nicely formatting the CMake lists, all about that. Okay, and finally we get to the profiler program. So what's going on here? Here's one of my fix-me's. This is kind of rickety looking with all the arrows. Sure, so you got arrows. Okay, sure. So what's going on here? He's just changing the way that we, now that we have a log of events, instead, when you look up, I guess he's changing the way that we look up libraries. So this is not particularly interesting. We need to look more at the rest of the things. So, oh my goodness, we're like halfway through. But if we look from the bottom, we can probably catch up in a different way. Okay, so here is the libc equivalent of the Unix types thing I was just talking about. So just having an identical copy of the same thing. Very silly. Here is that new widget he added. Maybe we should try his profiling thing here, see how it feels like. Profile-C, or let's profile the world. A is profile everything. E for enable. Oh, and I have to be root, of course. And let me profile the browser, going to the Serenity website, and exit. And then we will disable. And then I should have gotten a perf core for that. Wait. No, that's not how that works. Where's my profile? Proc profile, that's where it is. No? Wait, I'm so confused. I haven't done this in long enough and now I don't remember how to do it anymore? I would have expected proc profile to contain my perf events there. Profile-A enable. Okay, lots of profiling. Disable. So what's in that file? A lot of stuff. I can't open it. No processes. Well, this doesn't seem right. So I guess let's just do this. See what's in it. Okay, so we do have events going on here, like process create and profile. process create, lookup server. Yeah, so it's like it's creating all of these for the running programs. Launch server, shell. Yeah, terminal. Like, so do we have process exit also? Process exit only for my exiting profile program. No processes. So I feel like that doesn't work correctly. Let's see if profile-c works. So profile-c browser. Doof. That gave us a perf core. No processes. Suspicious. Okay, let's try to profile a running terminal. No processes. Okay. I feel like this does not work. So that's an issue. Let's see if, just on the off chance that this PR has been updated since I pulled. $3 ago. Nope. Okay. All right. Then. Let's see. No processes. Wait, where is that string from? No processes. Why can't I find that? Where is this from? Invalid perf core format? Am I running the same thing that... I'm confused. I don't see that string anywhere. And oh, and I did some pointless accidental change. I didn't mean to do that. Okay, I am a little bit confused, a little bit disoriented, so let's just build a new disk image and try again. Okay, let's see if we can profile terminal. Okay, that totally works. I have no idea why that did not work. It almost feels like we had an old profiler binary, but a new kernel somehow. So maybe I forgot to rebuild the disk image and I only built the kernel, and then I was running the kernel with an old copy of the profiler program. That's probably what was happening. Yeah, because that error message is no longer in the code. So I'm sorry for suspecting you, Gunnar. I don't think you did anything wrong here. That was just me not rebuilding the disk image. Okay. So let's actually capture a full system profile like I wanted to. And we do some stuff, blah, 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 and disable proc profile. Ooh, look at that. Okay, so this is the fancy new profiler. And here is the new widget where you can select which process you want to look at. So I want to look at web content. Wait, I don't know what that... Oh, okay, so it changes what I see down here. It doesn't change the view up here. I sort of expected to only see samples from the process I was selecting, but this is fine too. So this is interesting. It reminds me of instruments on macOS. In instruments, you can actually get stuff like you can get like one timeline, like this thing here. Like now we have one for the whole profile, but you could also get one for each processor, one for each thread. And in the equivalent thing that they have for this list, you can also select, like check which processes you want to see. So you can check multiple processes and see samples from all of those. So that's might be an interesting thing to add as well. And immediately I'm thinking like it would be cool to have that the process would be the outermost node here in the graph, so that instead of seeing like start, you would see an even outer node called profile for like the profile program. And then you would have different starts for each process, because right now we sort of merge together. If you look at all processes, it gets a little bit confusing because these could be all totally different programs and their samples are all merged into this call graph. And it is interesting in a way to do holistic profiling of like whole system GUI performance and stuff like that, but I think it would be very valuable to separate these by process and even by thread, sort of like how Instruments does. Anyway, okay, so yeah, so that's that widget. Now we are oriented. We can go back to looking at the code. I guess that's the process picker widget. So let's see how that looks. Process picker widget. Clickety clack by Mr. Gunnar Beutner. Let me add his last name to the dictionary. Okay, very good looking libGUI widget right here. I love when people pick up Serenity and quite quickly learn to write like in this completely idiomatic style. It's so fun to see, and I do think that the project is really it's really good at that particular aspect of like bringing new people in. Like seems to me like people can always figure out how to write idiomatic GUI programs in the system, and this is a very nice looking widget. Even has the private constructor, which we usually do. Very, very nice. Okay, so what's going on here? Nothing particularly special. It's just a GUI frame that has a horizontal layout with text process here on the left, sure. Combo box on the right. Only values from model, sure. So it has a data model that supplies the executable names. It's a simple item list model, sure. And when the combo box changes entry, then we clear the process filter if you select row 0. So that would be all processes, makes sense. Then we don't filter. Otherwise, we we look in the item model, item list model thing, sure, and just work out what is the PID that we should be filtering. And then we have a process filter on the profile object, which is a PID, start valid, end valid. What are those? Start valid. I guess that's like when that process was born and when it died, because we don't need to include anything that's outside of that range. It's almost like an optimization, but it's a very sane optimization. Like there's no need to filter anything outside of the range. Also, that does protect you against recycled PIDs to an extent, which could happen. Anyway, okay, so that's cool. And here he's adding process ID to the samples model. So if we look at samples here, we can see now that oh, this thing is not sortable, but it's clickable as if it is. That's annoying. Right, so we have PID and TID here. Previously we had only TID, I think. Yeah, we had thread ID, now we also have process ID. That's very good. And look at that. Gunnar's fixing my fix-me's. More abuse of the PID-TID relationship. I love this. Very, very awesome. That's so good. Okay, filtered event indices, and my eternal internal struggle about should you say indices or indexes, and I can never decide. And I don't know. Indices. We have indices, like 67 matches in the project, and indexes 100 plus matches. Yeah, so I personally kind of think that indexes works better when you're programming because it's more readable to somebody who's less used to English, maybe. But indices looks better as an English word to me. But it feels like indexes is more simple, more legible somehow. But this does look good to me. I don't know why I'm stopping here to to talk about this. It's just, I always, whenever this silly word comes up, I always pause and think, should I do indexes or indices this time? Anyway. Okay, so the row count of the samples model goes from being the filtered event count to being the filtered event indices dot size. So what is the filtered event indices anyway? It's a vector of indices, presumably. Right, so it's just a vector of size t with all the indices, no big deal, and we get it as a const reference, which makes this very nice and cheap, so that's great. No big ugly vector copy happening here. And then these are just the percentage computations. So if we switch this thing to percentage mode, here can switch between percentage and absolute sample count. These percentages look a bit too specific. I think that's my fault. I recently changed the way we produce percentage values, or the floating point, how we convert floating point to string in the GUI library. So this is the default behavior, to just be more specific, and it looks dumb, so we should probably fix that. But just noting that right now, because I don't care about this much precision, right? It could say 96% and that would be fine, but 96.05, maybe that would be the best. Not sure exactly. There's a big difference between 1.0 and 1.9 though, so we definitely want to have at least one decimal. Sure, and then this is just a new metadata here about a profile. Do you have a process filter? If so, what is the filter PID? Start and end valid. So here I'm going to say something I always say, please always explicitly initialize primitive variables. Because uninitialized data is so annoying, and if you don't initialize your things, you eventually fall on your ass. It has happened to me a billion times, and if you don't initialize your data, it will happen to you too. It's just a silly problem to have, and you can just skip having it by initializing your things explicitly. Okay, sure, processes vector, blah blah blah. Set process filter, clear process filter, has process filter. Yeah. So this is the profile object. We're just adding a bunch of stuff to it so that we can we can add a process filter to it. And then what is this struct right here? Bool and kernel. Where are we? Let me expand here. Oh, event. Okay, so profile events now gain a name, parent PID, parented, string executable. What is that name thing? Name, event. What is that used for? Let's see. Okay, I think maybe you are getting confused. Event.name is, okay, so we're storing the name from the JSON, the event type, I think. proc profile p. Let me look at that. Oh wait, no, that's type. So what is name? Oh, name's this. Okay. So it's like if you have an mmap, then we store the name of it. So we do want to store that. I thought at first that he was storing the type string. This would have been a silly thing to store. Definitely in this case we should store numbers, not strings, but for the names we should store them as strings. So that makes perfect sense. Parent PID, parented. Oh, why do we need that? Parent PID. I'm surprised that we need that. What is that for? Parent PID. Process create. Okay, so we're just logging the parent PID. So when we create a new process, we log who the parent was. So that's interesting information, but it seems unfortunate to include that in every profile event that this program deals with. It also appears to me that it's not actually used for anything. Parented. We're just storing them but not using them. So we should make a note of that here. These don't appear to be actually used for anything. Sure. Okay, and then messing with the find process to add a timestamp. Wait, why do you need a timestamp for that? Profile node. Find process, PID, and timestamp. That's so... It feels so robust to care about that, but I like it. Like, what's the PID and when? It's making me think about PID FDs, which they're doing in Linux, which is like an unambiguous way to refer to a process, right? Because because PIDs are integers, they will eventually repeat. So a PID is ultimately ambiguous, just that it takes a long time for the ambiguity to materialize. It would maybe something that we should think about for the future, to have a completely unambiguous process ID somehow. But a PID and a timestamp disambiguates, so that's fine. Okay, just removing some old way of storing the metadata, sure. Here's the process picker widget, we already looked at that. What is this? Process.h. Oh, okay, so it moved here. Just profiler now has process.h where we store these structs like process, thread, and library metadata, mapped object. Yeah, these classes are pretty awkward. Like, they grew very organically, almost like fungus, while I was adding functionality to the profiler. So a lot of this code is very like unstreamlined. You could definitely improve it and make more generic, but didn't touch that recently. Inline in class or struct declaration is implied. No need for inline. Same thing here, but I already said it. So very often, like if I say something once, I sort of believe that the person reading will understand that, like, hey, if I have done this thing elsewhere, I could fix that up elsewhere as well. And I certainly trust Gunnar to do that. I wonder if this needs to be an inputter or if it could be a non-null inputter. Like, do we ever need to have null libraries? mLibraries set. Do we ever call that with something not? Do we ever insert null here? I don't think we do. but I guess it was on per before too. But I'm just still gonna make a note of it. Do we ever need to insert null library pointers into here? Otherwise, perhaps it could be hash map null onPutter to library. No need to fix now, just making a note. Cool. Yeah, blah, blah, blah. So this is just stuff that's previously was mixed with the rest of the code and it's just moving to its own file. So we don't need to pay too much attention to that. So that actually bloated up this thing quite a bit. So just moving stuff to a separate file. So my comment here about this is that like this could have been a separate commit, right? So when I started looking at this, I said this could probably be 2 or 3 commits. Moving a bunch of stuff to a new file, definitely a good candidate for a separate commit. So let me make a note of that. Process.h. Let me put it right here. Moving this stuff to separate files would have been nice as a separate commit instead of mixing it in with the rest of this already large change. Yeah, because that would have made this a patch significantly smaller. So now it was like intimidatingly large when we were at the top of it. And by the time we get near the bottom, we realize, or by the time we get halfway through, now I realize, wait a minute, he's just moving stuff to a new file. Okay, but yeah, I think we get the gist of what's going on here, and we've seen that it's working. So at this point, I'm basically comfortable with this change. We do have a null dereference in the kernel, which obviously means that we should fix that before we merge it, but I think this does look good otherwise. Here is one of my personal pet peeves. You don't need to have else after you have continue, break, or return, right? Because it's sort of implied. No need for else after continue. Then again, that does screw with the symmetry. It does screw with the symmetry of what's going on here because he's like essentially matching on event.type. So I'll just swallow that one. That is sort of the one situation where I think it's okay to do this, is if you're you keep checking this same left-hand side thing against a bunch of different right-hand sides. Okay, time for the time for the style police. In situations like this, I usually like to put a comma after the last struct initializer, struct member initializer, to trick line format into starting a new line. And just to show what I mean, this is slightly non-essential, but something I like to do, so I'm just gonna mention it anyway, because I do think it does look nicer if you do this. So what you do is you put a comma after the last one, and then client format will do that instead of this. I think it's slightly nicer. Yeah, so this does look very nice. don't think I have anything more to talk about here. I mean, now we didn't like go through the user space code with a fine-tooth comb, but I think that's not necessary. I feel confident that since it works, like evidently, it is probably mostly good, and if we have bugs, we can fix those. I think the kernel parts I wanted to look at more closely because it's a bit more sensitive, right? Because everybody runs the kernel all the time, whereas the profiler, if you screw up the profiler, you only mess with the use case of profiling. So yeah, I think this looks really cool. So let's finish up our review with a comment saying this looks super awesome. The only real problem I found was the null dereference on VM allocation in symmap. Why is dereference not in my dictionary? Holy moly. Let's put one of those. Okay. Yeah, so this was the code review of this PR. So now we just gonna iterate probably just one more step and then we can merge it. But I'm not gonna sit here and wait until he comes back. Instead, I'm just gonna end the video here because this is how my day went today. So now you got to see how that was. So thank you very much for checking out this video. If you like the format, do let me know. And if you think that there's something we could do better, do let me know as well. The main thing I didn't quite know here was like how much context to give about everything, because obviously I'm more familiar with this code, so if I were not recording, I would not explain so much, but to make it easier for you to understand, I try to just provide context about everything, and I hope that was that made it more understandable. Anyway, please, all comments appreciated. Let me know what you thought, and if we should do more of these in the future. And thank you very much for hanging out. I will see you next time.